property about fractions and dividing radicals that I'm going to put at the top. So if you ever have a root of a fraction, that is the same thing as root A over root B. Now sometimes it's efficient and beneficial, rather, to split it up into two separate radicals. And sometimes it's beneficial to kind of go backwards with it, and if it's already two separate radicals, put it into one. We'll see examples of both of those. On this first one, I guess you would first try to simplify your fraction, 121 divided by 9, but you can't. So you're going to kind of go this direction with the rule and split it up into root 121 over root 9. And then simplify each radical separately. The square root of 121 is 11, square root of 9 is 3, and you're done. On this next one, you could simplify it separately as it is, but you're going to see, and this happens sometimes, that if I kind of combine it into one fraction, your life's going to be easier if you simplify the fraction first, right? Because 72 divided by 8 is 9, and x cubed divided by x is exponent rules. What's x cubed divided by x? X squared. We technically, when you're dividing common bases, we subtract those exponents, right? And now this is much easier, a much easier radical to simplify. The square root of 9x squared is 3x. If you didn't simplify your fraction first, then you would have had to have broken down 72 and the x cubed and the 8, and you would have had to do all that. You'd end up with the right answer, but it would have taken you quite a bit longer. So if you can reduce the fraction first, please do. Make your life easier. Now, this one. Can I reduce this fraction? What's 500 divided by 10? 50. What is x cubed divided by x to the negative first? X to the fourth. Excellent. There's our dividing common bases. Subtract your exponents. 3 minus negative 1 is 4. Now I can just simplify this. How do I break down 50? 25 and 2. How do I break down x to the fourth? I don't, right? It's already an even exponent. So I have 5. What's the square root of x to the fourth? X squared, and then I have a root 2 hanging out. There's my answer. So that is the easy part. Here's the, and there, it's all easy, I should say. Here's the kind of more important part. You notice in your title, your notes, dividing radicals, we just did that. Not that difficult. And rationalizing. Rationalizing is the process, write this down, process of rewriting without a radical in the denominator. Because math people tell us somewhere along the line that having a radical in a denominator is unacceptable. Okay? It's like someone along the line said having a negative exponent in your final answer is unacceptable. Well, having a radical in your denominator is unacceptable by math standards. So we are never allowed to leave a final answer with a radical in the denominator. So if you look at number 4, we have a radical in the denominator. Okay? You also have a fraction here. So if we could reduce 4/5, we would want to do that, but we can't. So there's a kind of an interesting way, and it'll make a lot of sense once I show it to you, of getting rid of the radical in the denominator. And it's going to happen by multiplying by 1. We're going to multiply this fraction by 1. Well, you think, like, when you multiply anything by 1, it becomes itself. So how is that helpful? Well, we're going to multiply by 1 in a creative way that's going to get rid of this radical. So I'm going to multiply by radical 5 over radical 5. Does everybody agree that I multiplied by 1? Because anything over itself is 1. So I'm multiplying by 1. So I'm not going to change the value of this fraction, but I definitely am going to change its appearance. Because on my numerator, what's root 4 times root 5? Root 20. And on my denominator, what's 4 root 5 times root 5? 4 root 25. And now when I simplify, what does my denominator become? 20. And I've eliminated the radical in my denominator. I have one in my numerator, no big deal. Root 20 breaks down into root 4 root 5, right? Which will just be 2 root 5 over 20. Ooh, I circled that as if it's my final answer, but it's not. Why not? What can be simplified about this further? 2 over 20? 2 over 20 reduces to 1 over 10, so just root 5 over 10. That's my final answer. Now, did anyone have any thoughts now looking back at the original question? You don't need to write anything else down, but Nathan, what do you notice about the original problem? Oh. So you would square this? Oh, square the denominator? So make this a 16 and put it underneath? Oh, interesting. I'm going to do it a different way as well. So he's saying if I do root 4 and kind of do that exercise that I talked about yesterday where what would this have been before I brought the 4 out kind of thing? It would have been a 16 times the 5 underneath there would have been 16 times 80. And then it would have been root 4 over 80, which would have been 4 over 80 reduces to root 1 over 20. We still would have ended up with the same problem though. Because when you simplify that, having a fraction under a radical, is the denominator still under a radical? Yeah, so that would have been root 1 over root 20, which would have been 1 over, and it would have been 2 root 5. So we still would have to get rid of that radical 5. What I was thinking was just, this problem starts with the square root of 4. That's a silly thing to have there, isn't it? So if I make that, root 4 is the same thing as 2, right? 2 over 4 root 5. Now I can simplify the 2 fourths to 1 over 2 root 5, which now immediately, Nathan, I'm exactly where yours would have left off. But I still would need to rationalize from here, but multiplying by root 5 over root 5. So my numerator is going to be root 5. My denominator, now, we talked about this shortcut. Root 5 times root 5 is what? Just 5. Times the 2 that's already there is 10. And that's what we had in our final answer, right? That's what we got, root 5 over 10, right? We kind of dropped the ball on not recognizing that root 4. So what it created for us was this need to break down root 20 and then reduce later on. Whereas if we had done it right from the start, we wouldn't have had to do that. But we all end up in the same spot, so no big deal. Okay? Number 5. This is a problem. So what can I multiply by? What version of 1 can I multiply by that's going to get rid of root 17? Andrew? Radical 17 over radical 17. Very good. Now this one's just a little bit more, because in my numerator, what is my numerator? It's a binomial. This is a binomial. So when I multiply it by root 17, I need to distribute. Yes? So negative 3 times root 17 is going to be negative 3 root 17. And negative root 2 times root 17 is going to be negative root 34. Now in my denominator, root 17 times root 17 is 17 times the 3 that's already there. I'll do that in a minute. That denominator is just going to be 3 times 17. Okay? Can I break down root 17 and simplify that at all? No. Is there any perfect square that goes into 34? I don't think so, right? So unfortunately, this is what it is. So your answer is negative 3 root 17 minus root 34 all over, and 3 times 17 is 51. And that's your final answer. Grace. Here times here. I guess technically it would be 3 times root 17 times 17 is 289. Yeah. Technically there is an intermediate step there. Root 289 would be what root 17 times root 17 is. But then the square root of 289 is just 17. So that's a shortcut I was talking about earlier, that root ABC times root ABC is just ABC. Okay? Why is 6 different? Not necessarily the negative denominator, because I could have just as well put a negative sign in front of this one. But this denominator is a monomial with a radical. This denominator is a monomial with a radical. This is a binomial. So if you just try to multiply by radical 5 over radical 5, you're going to have to distribute that radical 5 to your denominator. It'll take care of the second radical 5, but it's going to create a radical 5 when you multiply it by negative 1. Does that make sense? So if our denominator is a binomial, we need to use something that we've talked about already this year, known as the conjugate. Very good. If your radical is in the denominator and it's part of a binomial, we need to multiply by the conjugate of that denominator. Jordan, what's the conjugate of negative 1 minus root 5? Nope. Who can tell me the conjugate of negative 1 minus root 5? Maggie? Yes, negative 1 plus root 5. And I'm still multiplying by 1, but I'm doing it by multiplying by the conjugate over itself. Good? Any questions? Okay. So in my numerator, I have to distribute. Root 3 times negative 1 is negative root 3. Cameron, root 3 times root 5 is root 15. Excellent. Now, here's the beauty of, what have I always said? What's the beauty of conjugates when you multiply them? What? Where else did we use conjugates? I can't remember. Let me do it here. X plus y times x minus y. When I multiply conjugates, my first term is x squared. My outer is minus xy. My inner is plus xy. And my last is minus y squared. So what always is going to happen with your outer and your inner? They cancel. So here's the beauty. My first times my first is 1. I'm not even going to write this down. My outer is negative root 5. My inner is positive root 5. They always cancel out. And then my last, what's negative root 5 times positive root 5? Negative root 25, but what's root 5 times root 5? Shortcut. Root 5 times root 5 is 5, and it's a negative times a positive, so it's just minus 5. That makes sense? So when I FOIL there, my first times my first is good, my outer and inner cancel, so I really only then need to do my last times my last. And negative root 5 times positive root 5 is negative 5. So all I need to do from here to get to the final answer is nothing to my numerator, negative root 3 plus root 15, and my denominator is negative 4. So have I gotten rid of the radical in my denominator? Yes. Okay, questions? All right. So you have to differentiate when your denominator is a monomial, just multiply by the radical over itself. When your denominator is a binomial, multiply by the conjugate. So John, is this a monomial or a binomial? Okay, so we're multiplying by the, which is what here? Perfect. Now, both the numerator and the denominator were binomials, so I have to FOIL both of these. So in my numerator, 2 times negative 2, Andrew? Negative 4. Next term, Aiden? Nope, look up at the board. I did 2 times negative 2, and now I'm doing 2 times radical 5, which is 2 radical 5. Next term, Madeline? Perfect. And the last term up top, Evan? Excellent. On my denominator, my first term, McKenna? 4. My outer and inner, I'm skipping, because these are the conjugates. This is where they're going to cancel. And then I just need my last times my last. And what is that? Kaylee M. Okay, but take the shortcut. Root 5 times root 5 is 5. So just minus 5. Anything that can be simplified or combined in my numerator? No. 15 breaks down to 3 times 5, but that's not helpful because I don't know the square root of 3 and I don't know the square root of 5. So my numerator is just this ugly, long, 4-term polynomial, and my denominator is negative 1. How else might you see that written? How would they not leave it over negative 1, Cameron? Right. They would literally divide every term by negative 1, which is going to switch every single sign. So it would be positive 4 minus 2 root 5 minus 2 root 3 plus root 15. And then the answer is not a fraction anymore. That's the simplest form. Okay, that's not always possible. Like up in the previous example when we were dividing by negative 4, that's not possible. Okay? But actually, one potential way, they could divide the negative on this one. So they could write it as a positive root 3 minus a root 15 all over a regular 4. That I could see them doing. Okay? And on the last fraction, what are we going to multiply by to rationalize this one? Kirsten. Radical 7 plus radical 3 over itself.